All right, I feel like I'm coming out of a cave here. This has been a pretty complicated but fun problem I wanted to solve for a long time. I've been wanting to figure out how to draw the attack vectors and critical hit zones as well in the angles of this game. So I finally got it. It took I think 3 weeks, honestly. Starting with the which I've done previously. I've talked about the this circle menu here. And there was some shader work done using Unreal's material, the way they do their materials. Let me see if I can find, let's see if I can find the, yeah, here we go. Yeah, so using their node-based editor, I mean, you can accomplish these things, but I have a hard time, like, personally understanding or maintaining this. So it can be done. Like, I did modify it so that it supported what we needed for the menu, but that was a simpler problem. So this was great, and that the YouTuber Your Sandbox, like it's just it was a godsend. Like this was amazing, and so I'm still going to use this, but this other radial representation is much more complex. There's a lot of data points involved here because of the way you can mix and match weapons and armor. So we need a way to represent how you can attack and how ships can attack. So I'm going to walk through the code just a little bit for and how you get about doing this. So I learned a really hard lesson. The hard lesson was that you don't have to normalize values in these float inputs for whatever reason. And I was trying to remember why I thought this, but I thought it had to be a value between 0 and 1. There must have been a system somewhere where I was working under that limitation. And so what you're looking at here is a normalized value. And what that means is it crams all the possible values between 0 and 1. So to get the true value out, let's get a calculator. And we're going to multiply this times the maximum. So in our case, this, oh dear, hold on, 0 dot, I didn't copy the 0. Okay, that's not helping. Hold on. Okay, so let's paste this times 255. Okay, so is this right? Is it 256? No, it's 255, yeah. So we multiply this value times 255. And we get this here. Now I think it's what's happening, it's like a rounding error. So I inside of the shader I call a round and fix that. So let me just look at the algorithm here. So we'll focus in on this guy right here. We need to convert it into a bit mask, which is going to like determine which angles there are. There's a picture I drew that, let me pause and pull that picture up. Okay, and here's that picture. So what we're looking at, you want to pay attention to the red numbers. I'm going to talk about the blue numbers in a little bit. There's 8 possible major attack angles here that we're concerned about. And so when we see the number 130, what we're doing is we are talking about this bit mask here. And this goes really low level into how binary works and stuff. But basically, the number 130 you get specifically by adding 128 and 2. And so what that says is that this angle is active and this angle is active. And so we can cram that into a single number, which on the server side is really useful for doing angle checks. And so that's what this number 130 means. But what I had done, which further complicates things, is shove it into a normalized value, which it's not hard to do in code, but it is difficult to deal with by hand, as you've seen. You have to kind of multiply it and then deal with rounding errors and all of that. So those wide angles are the attack vector. Now, this is me messing around, so there isn't a ship with this configuration yet. There could be with like mods and stuff. So I wanted to support like pretty much every possible combination with this data. So by just inputting into these 4 values here, you can get these angles. So like here is the extra range. And so what this will represent, this first little circle here will represent 0 through 25 meters. I think I have notes here. The second range will represent the mid-range, 26 through 50, and then etc. So we have these. Anything that goes beyond will just fit into this thin line out here. And so that's kind of our little visual there. And you can easily control this. And so if we wanted to say that only the center had extra range for a certain ship, let's see, I think we're going to do, this is the value we want. So yeah, I see how it's a bit of a pain to like normalize this. So now we're saying that the center has an extra range, but the other angles don't. And if we will, yeah, so it doesn't do that. 0, okay. Now, all right, so I've got that part figured out. This was the code for it. Basically you draw a circle. Shaders are interesting. You basically add and subtract basic shapes that you can generate mathematically. You can also pull in textures, but I didn't use any textures for this. It's really just I drew a circle and drew another circle and then erased the center of the circle. So what you're looking at is actually a bunch of circles, but we're creating rings from those circles. And so you redraw this arc for each range. So there's one arc here, 2 arc, 3 arc, and then a 4th. Then for the red color, we do it again. So what we do is we have to detect, this is a pixel shader, so each pixel, we have to figure out where it's at in the angle, and then run it up against the bit mask to see if we should render it or not. And so if I created let's just create a quick vector parameter here, and let's wire it up, and we'll just turn on the full bit. So if we turn on the full bit, this is the full potential of like everything that could be drawn. But as you've seen, you can kind of mess with it. So if we wanted to do, like, you can only attack from behind. That would be 16. And get this normalized value. And we could like drop this in. And so now it's only, the attack vector is from behind. And maybe I only want to say, maybe this is like a reverse sniper rifle or something, which would just let me backspace. So it only does these ranges. And so it has a ton of combinations that you can work with in here. Okay, so here's this code. It was pretty difficult to figure out. I had to do a lot of a lot of math, but ultimately, what I found is that you don't have to normalize the value. So I didn't have to do this. I could have just passed in 255 inside of my inputs here. So that was a big learning. That was a big learning lesson here. Okay, and so next, since I figured this out this morning, I started to add animation. So the only difference between what we have here is I wanted to make it kind of pulse. So this ease sign in and out, which I've copied from my other GLSL from the web, and then just like made some small adjustments so that it would fit in here. We just take time as an input, which is already being passed in here, and then we would just run this algorithm. So, I mean, I found this algorithm a while back and have just continued to use it over and over again. So we just mess with the parameters till it feels right. Turn this time to on, and then you kind of get some motion there. And so what it's doing is it's drawing the maximum size of the circle, and when it's subtracting, it's still doing the subtraction. So you get that spacing in between. So that's cool. That's what I'm looking for. And then I'm going to do the same thing for, there's the arc slice here. And so I'm just going to pretty much copy and paste this. I'm going to grab all this code, come into here, Control A, Control V, and then paste it down. So now we should have it all for the the red too. It'll also do the same thing. So kind of stick with it. And you sort of get this like little pulse effect. So it looks like it's extending a little past the that's the boundary on the shader. So I'll probably tweak it so it doesn't do that. But otherwise, I'm pretty happy with this. Able to represent the angles succinctly, and there was a challenge getting information about how to do this sort of thing. Like you can Unreal supports these raw shader nodes, but they kind of caution against it, saying that it's not optimized. And so for our case, these are going to be pretty small, and we're going to be using it like inside of a card, so it shouldn't be terribly awful for performance and stuff. The biggest issue for me was like having to paste the code in here. They do seem to offer this include file paths here, which I mean might work, but I don't know from what reference point it's doing that. It's hard to find that information. Um, so yeah, I just write it in VS Code. I save it myself and just move it over when I'm ready, and that seems to work fine. You have these parameters. I use a convention v underscore to describe how the variable is coming from Unreal, because there's nothing in here to indicate like an import. So it's not a full shader script, but it does work. And then you can have all your layers here. And yep, so that's it for this one. I suppose I'll get back to working in the 3D realm, and I can finish the card design that we have.